Alrighty, fourth graders, hello, hello, hello. I hope you're having a great Friday. We are on day 5 of week 3. Looking in instructional book, page 292 through 293. Practice book, page 295 through 296. And then we are on day 6 of our countdown. So this week we've been talking a lot about line plots and how to organize data on line plots, and we've looked a little bit into how we can use line plots to add and subtract different parts of our data. So we're going to specifically look at adding with line plots today. Page 292. Are we ready? Let's do this. So Sophia is making a border for a quilt. She wants to use leftover strips of fabric that are all 2 inches wide. I feel like that might be important. She measures the length of each strip and records the information in the line plot. If Sophia puts all the strips together, what will be the total length? So they want us to put all these strips together. So when we put all things together, we are doing what? We are doing addition. But if you look at this line plot closely, we have 12, 12 and 1/8, 12 and a quarter, 12 and 3/8, 12 and a half, 12 and 5/8, and 12 and 3/4, and 12 and 7/8 going all the way to 13. Now, we saw this before. If we go back to what we did yesterday when we were representing data, this is page 290 in the instructional book, we had a line plot that had different fractions with different denominators. And what did we do? We went and we found the equivalent fraction of the smallest unit represented by the data. And you could actually even use the key that we filled out on page 291 in the instructional book. If you remember that first question that we did, we found out that a half is the same as 4/8, a quarter is the same as 2/8, and 3/4 is the same as 6/8. We can use those fractions because the smallest unit in this line plot is an eighth. Okay. So now that we kind of have that plan, I'm going to go ahead. I'm going to do it on. I'll do it on this side. We know that this half is the same as 4/8. Okay. The 3/4 is worth 6/8. And the quarter is worth 2/8. And you could also use multiplication to figure this out. If we have a half and we want an equivalent fraction of a half with 8 as the denominator because eighths are our smallest unit, well, what times 2 equals 8? 2 times 4. So if I multiply, I'll do that down here. If I multiply 4 by the denominator, I'm going to multiply it by the numerator too. So 4 times 2 is 8, 4 times 1 is 4, and we get 4/8. The picture, it says you can use the picture to help solve addition problems with line plots. The picture shows the strips of fabric placed next to one another to make one long strip. So what they did is they took this, the line plot, and remember, each one of these X's is 1 unit, or 1 strip of fabric. So we had 2 12/8 strips. We had 3 12/4 strips. 1, 2, 3, 1, 2, 3. We had 1 12/3. We had 2 12.5, and 1 12 3/4. It says you can break up the whole numbers and fractions to help you add the lengths. So all they did was they pulled the whole number out, that 12, and they added all the 12s up. Well, we had 1, 2, 3, 4, 5, 6, 7, 8, 9 12s. So you could either use repeated addition, or you can just say 12 times 9, which is 9 times 2 is 18. Carry the 1. 108. And then you add the fractions. But what happens with the fractions? Well, we can't add fractions that have different denominators. All of our denominators have to be the same. So we're going to go back to our key. And I don't want to get too far ahead because this usually breaks it down for us. So let's go ahead and look at page 293. Number 7. It says, write the fractions on the number line in eighths. Why should you do this? Well, first let's go ahead and replace. We know that a quarter was worth 2/8. So this is the same as 12 and 2/8. And 12 and a half is the same as 12 and 4/8. And our 3/4 was the same as 12 and 6/8. And you could either have used your key, or you could count by eighths. Well, this is 12, 12 and 1/8. That would be 12 and 2/8, 12 and 3/8, 12 and 4/8, 12 and 5/8, 12 and 6/8. You see how it goes? Look at your numerators. See how they fall in line with that pattern? Now, we want to do this because in order to add the fractions, they all have to have the same denominator. So we have to change the fractions to eighths, or to units of eighths, in order to add them. Then it says, write an expression to find the total lengths if Sophia puts all the strips together. So we're going to, just like we had done, just like they had done, we're going to create our number sentence that's going to help us solve this problem. Well, we have how many 12/8? We got to go back and look. We had 1 and 2, right? Sorry if I have to keep flipping over. And then I had 3 12 and 2/8. I had 3 of those. And then I had 1 12 and 3/8. And then I had 2 12 and 4/8. And then we finally had that last one, 12 and 6/8. Number 9 is asking us, what is the sum of the whole numbers? Well, let's pull our whole numbers out. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we could still do our 12 times 9, or you could use repeated addition to add up all the 12s, and we had decided that that was 108. What is the sum of the fractions? Well, let's add our fractions as 1. We're just going to go through and add all the numerators. Let me do this in a different pen so you guys don't get confused. That's 1. 1 plus 1 is 2. Plus 2 is 4. Plus another 2 is 6. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So we had 25/8. Remember, when we add fractions, our denominators do not change. Write the sum of the fractions as a mixed number. So we're going to have to change 25/8. Let's see if I can't zoom in a little bit. Into a mixed number. So 25 divided by 8. We know 8 times 3 is 24. And that just leaves us 1 left over. Or you can do it with the long division way, where it is 8 divided by 25, goes in 3 times. 8 times 3 is 24. We subtract. This is our whole number. Our left over is our numerator, and our denominator doesn't change. What is the total length, excuse me, what is the total length of all the strips? So all the strips added together, we got to add our 3/8 and 108. So 108 plus 3/1/8. We add our whole numbers together. 108 plus 3 is going to be 111, and our fraction does not change because we're not adding any more fractions to it. Number 10 is asking, how do you solve a problem about adding fractions or mixed numbers in a line plot? Well, basically what we did was we labeled the line plot using the denominator of the smallest unit fraction. So we labeled the line plot using the denominator of the smallest unit fraction. Then we did listed the numbers to add up here. The numbers to add. And then for the mixed numbers, we just added the whole numbers and fractions separately. We added the whole numbers and fractions. Fractions separately. Don't forget your punctuation, y'all. Don't want Miss Felicia to get onto us. Alright, so if we use what we just learned to solve these problems, use the line plot on the previous page, show your work on a okay. So these questions down here are going to be referring back to that same line plot that was on the other page. So number 11. What is the length of all the 12.5-inch strips combined? So we're just adding all the 12.5 strips, which were, how many did we have of that? That would be, so we had, our 12.5 was the same as 12 4/8. And if we looked at our line plot, we had 2 of them. So we need to add both those strips together. So if we did 12.5 plus 12.5, because we had 2 of them, 12 plus 12 is 24. That is 1 plus 1 is 2. Oh, but look. Oops. Our fraction becomes the same as 1. So if we just add those together, we get 25 inches. What about the length of all the 12.25-inch strips? Well, how many 12.25-inch strips did we have? We had, let's go over here, we had 3 of them. So we have 12.25 plus 12.25 plus 12.25. 12 plus 12 plus 12. You can either use repeated addition, which would be 2, 4, 6, 1, 2, 3. Or you could have just said 12 times 3 equals 36. And then when we add up our fractions, we have 1, 2, 3, 4 inches. Alright. So when we're adding with our line plots, you have to make sure that all of your denominators match. If they don't match, you need to find the equivalent fraction. When we add these mixed numbers, a little bit of review, when we add the mixed numbers, we add the whole numbers and the fractions separately. What else did we do here? Because we're fixing to close up this unit. We know that we need to make sure we're counting these as each unit. So if it's asking you like that number 11 and 12 that's asking you down here to find the length of all of the strips that are worth 12 and a half, we need to go back and remember we didn't have just one strip at 12 and a half. We had two strips at 12 and a half. Let's look at the practice page. The practice page is page 295. 295. Let's look at the example. Ashley is decorating a frame with seashells. She wants to know if all the shells will fit along the edge of a 16-inch wide frame. She measures the width of each shell and records the information in a line plot. If Ashley puts all the shells in a row with the total width of the shells, will the total width of the shells fit on the frame? So we have our widths of seashells. You notice our line plot, we have different denominators. Okay, remember if you count on the number line, if this is 1/8, this would be the same as 1 2/8. If this was 3/8, this would be 1 4/8. 5, and then this would be 6/8, 1 6/8. Boom. Just that easy, just to use that number line in those benchmark fractions to really understand the values there. They wrote the fractions in eighths, which is what we just did. So they went ahead and converted it for us. Then they added the total width of the shells is 15 1/4 inches. 15 1/4 inches is less than the 16-inch wide frame that she was working with. So all the shells should fit on the wall or on the frame just fine. Number 1, it says, look at the line plot in the example. Ashley decides to glue the 5 largest shells along the edge of another frame. The shells fit exactly. How wide is the other frame? So what we want to do here is we want to take the 5 largest shells and we want to add them up to see how wide the other frame is, because the shells fit exactly. So however long that shelf is how wide my seashells are going to be, because they take up exactly that spot. I'm just going to draw you a little model here. Woo! I almost didn't really make it, did I? Anyhow, so let's see, our largest. So how do we find our largest seashells? By using this line plot. Remember, this is going to be the smallest. This is going to be the largest. So we're going to count backwards from 2. So we had 1, 2, 3, 4, 5. So all the shells from here over are the 5 largest shells. She glued them all together, and so we need to add up all of these shells. So we have one shell at 1 5/8. Whoops, messed that up. 1 5/8. Okay, plus we had 2 shells at 1 6/8. So 1 6/8 plus 1 6/8. And then we had 2 shells that were equal to 2. So we have, that would be 1, 2, 3, 4, 5, 6, 7. Adding up my whole numbers first. Now I'm going to add up my fractions. 6 plus 6 is 12. Plus 12, or plus 5 is 12, 13, 14, 15, 16, 17 eighths. And we can make that smaller. How? Let's turn this. This is already an improper fraction. How can we change this to make it look a little bit better? Let's make it a little bit smaller. If we just take this out, let's go ahead and take our fraction out. Oh my gosh, you guys can't even see what I'm doing. Let's take this improper fraction out and just go ahead and divide it out. See what we get. Alright, 8 goes into 17 twice. That's 16. Subtract. So that would be 2 and 1/8. Because remember, 2 is our whole number. Our even, those go in exactly. This is what's left over, so that's our piece, our numerator, and then our denominator doesn't change. And all I'm going to do is I'm going to take that 7 and I'm going to add in this new mixed number. And when I do that, I get 7, 8, 9. and my fraction stays the same because I don't have any other fractions to add it to. So that looks a lot better than what we were working with before. This is a great fraction review. I like how they did this because we spent a lot of time on this, but it's always good to get that refresher because there were so many rules that came along with the fractions. So this is great. Alright, number 2, Ashley puts the 1 1/4 inch shells onto a string. What is the total width of the string? Or shells on the string. So we need to find all the shells that were 1 1/4 inch. How many did we have? Let's look at our line plot. We had 1, 2, 3 shells that were 1 1/4 inch. So we're going to add those up. We had 1 shell, that's 2 shells, and that's 3 shells. Oops, I almost messed up my 4. When we're adding mixed numbers, we add our whole numbers and our fractions separately. So our whole numbers, right here, 1, 2, 3. And our fractions, we have 1, 2, 3. Remember, we do not change our denominators. So we have 3 3/4 inches. Page 296. Alright, so it looks like they're giving us another line plot. Said a standard size brick should be 7 5/8 inches long. The line plot shows the actual length of 12 different bricks. So let's look at our line plot real quick. We already see that we need to change some numbers, right? Because our fraction denominators do not match. So what we're going to do is we're going to count by eighths and find our equivalent fractions real quick. So we have 7, 7 1/8. That would be 7 2/8 because it's between the 1/8 and the 3/8. 7 2/8. And then we have 7 3/8 and 7 5/8. So this must be 7 4/8. And then we have 7 5/8 and 7 7/8. So this must be 7 6/8. Oop, I'm smearing my pen. 7 6/8. And we don't need to change any of the other ones. Alright, so now we can zoom back out. There it goes. Number 3 is wanting us to find the sum of the lengths of all the bricks that are exactly 7 5/8 inches long, which is what they're supposed to be if you've read up here. Remember, a standard, don't do this to me, camera. A standard size brick should be 7 5/8 inches. Well, how many were? We had, remember, each of these X's represents one of those units, one of those bricks. So we have 1, 2, 3, 4, 5, 6, 7. We have 7 bricks that are 7 5/8 inches long. And you can write it out. You can say 7 5/8 plus 7 5/8 plus 7 5/8. I said 7, right? 1, 2, 3, 4, 5, 6, 7. Yeah. Always want to make sure you're counting right. That's 1, 2, 3, 4, 5, 6, and 7. And you can go through and add that up using repeated addition, or because this is repeated addition, we know that we should be able to do 7 times 7 5/8, which you could do it. Okay, let's do it this way real quick. 7, 7, 7. Adding all the 7s together is 49. That'd be 49. And then we add up all of our 5s. That's 5, 10, 15, 20, 25, 30, 35. Denominator doesn't change. And then we just turn that into a... to pull out our improper fraction. 8 goes into 35 4 times, so we have 4, and that would leave 2, right? No, 3. 8 times 4 is 32. To get to 35, we'd have to add 3, and our denominator doesn't change. And then we just add in our mixed number again, and that all equals 53 3/8 inch. As plural, because there's more than one. You could have done it this way, or you could have done, alright, I had 7, 7, so 7 times 7 is 49. I had 7 5s, 7 times 5 is 35. And then you could have put those together and then done that same bottom step. Alright, number 4. What is the sum of the lengths of all the bricks that are less than 7 5/8 inches long? It's not saying less than or equal to, it's just saying less than. So we're going to go back to our line plot, and we are going to look at all of the bricks that are less than 7 5/8. So we had 1, 2, 3 bricks that were less than. We had 1 brick that was 7 3/8. I'm just adding it down here. And then we had 2 bricks that were at 7 1/2, and 7 1/2 we said was equivalent to 7 4/8. So 1, 2, 7 4/8 plus 7 4/8. 7 plus 7 plus 7 is going to be 21. And then 4 plus 4 is 8, 9, 10, and 11. 11/8. We're going to do the same thing we did before. We're going to pull that improper fraction away from our whole number. 8 goes into 11 one time. So that's going to be 1. And that would be 9, 10, 11. It'd be 3/8. You can do that mentally, or you can do it the long way, which is the 8 goes into 11. 8 goes into 11 one time. Multiply it out. Subtract 3. And then you just pull your numbers together. So now we have 1 3/8 plus, don't forget to add back in that whole number. 21 plus 1 is 22. And our fraction stays the same because we have nothing left to add to it. Number 5, what is the sum of the lengths of all the bricks that are greater than 7 5/8 long? So we're going back up to our line plot. This time we're looking for bricks that are bigger than 7 5/8. So we're going this way because we want our bricks to be larger than 7 5/8. They need to be larger. And we have 1 brick that is 7 6/8 and 1 brick that is 7 7/8. So we have 7 6/8 plus the other brick was 7 7/8. And we're just going to add those together. 7 plus 7 is 14. 6 plus 7 is going to be 13/8. We're going to pull our improper fraction out. 8 goes into 13 one time. 1 times 8 is 8. 13 minus 8 is 5. And then we need to come back and we need to add that whole number back in. So it's a total of 15 5/8. So that was a lot of fractions in there, wasn't it? A lot of mixed numbers and having to change improper fractions back into mixed numbers and vice versa. So I hope this video helped you out a little bit if you struggled back when we did this skill. I will be doing another fraction video that's just fractions, that's just going to be like a review type deal. Hopefully that will be up Wednesday next week. We shall see. My internet has been redonkulous. I'm going to change colors. Let's do blue. I found me some colored pens. I was super excited about that. Alright, so last part of it for Friday. Countdown day 6. Jack bought 2 umbrellas, each costing $13. He bought 3 hats, costing each $4. How much did Jack spend in all? So first we got to pull out our umbrellas. Our umbrellas, we had 2 of them, and each of them cost $13. I keep saying each because this is what kind of word? Oops. This means to multiply. So 13 times 2. 3 times 2 is 6. 2 times 1 is 2. So 26 was the umbrellas. I like to try and, especially when I have a bunch of different values, that way I don't get them confused. Now we need to look at the hats. We had 3 hats each. There's that each again, meaning that we will multiply. So 3 times 4, which is 12 for the hats. And then we just need to combine the umbrellas with the hats. Six plus 2 is 8. 2 plus 1 is 3. So he spent $38 all together on umbrellas and hats, which wasn't that bad. I think hats generally cost a little bit more than that, especially some of the hats you guys come to school with. Good Lord. Those look like they cost more than my car sometimes. Number 2. Chad has $53 and each, there's that multiplication term again, and each umbrella costs $12. He writes the equation shown, 53 divided by 12 equals 4 remainder 5. What does the number 5 represent in terms of Chad's money? So, Chad had $53 and each umbrella cost $12. He writes the equation. So it looks like he's trying to figure out how many umbrellas he can buy with his $53, because it looks like he's trying to split it up into groups. If each umbrella costs $12, then how many umbrellas can he buy with $53? This remainder for his money, you got to imagine, this is saying he could buy 4 umbrellas without going over 53, and he would have a remainder of $5 $5 left over. So the 5 represents the $5 he would have left over after buying 4 umbrellas. Number 3. Jenny bought 3 umbrellas and 4 hats. The umbrellas cost $15 each. There's our multiplication term. And the hats cost $5 each. Write an equation to show the total cost C in dollars of the items Jenny bought. So what our equation is going to look like, we're going to have to pull out the umbrellas. So we know that the umbrellas are going to cost $15 each, so 15 times 3. But then we need to add in the hat cost too. So we need to plus, and I usually like to group when I have, we want to group. So this is umbrellas. And then the hats are going to cost $5 each. So 5 times, and how many hats did he get? He got 4 hats. And when we add all that up together, we will have the cost. It's not asking us to solve it, but if we were going to solve it, we would take the umbrellas, 15 times 3, 5 times 3 is 15, carry the 1, 3 times 1 is 3, plus that 1 is 4, plus the hats, 5 times 4 is 20. So the cost is actually going to equal $65. Alright. Number 4 is just asking us to go through and decide which equation is true and which equations are false. You could go through and solve them, like 40 minus 27. Ouch. Hang on. I think something just froze. Did it freeze? No. Okay. I had to wiggle it around for a second. So, we have 40 minus 27, which is 13. And then 9 plus 4, 9, 10, 11, 12, 13. So that's true. 44 minus 22 is 22. Having to use some of that mental math. 32 minus 10 is going to be 22. So this one checks out. 86 minus 69 is 17. And then 58 minus 43, that's 5. So 15. I think we found one that was wrong. Let's make sure my mental math isn't wrong. Let's look at D real quick. 93 minus 35 is 58. And then 24 plus 34 is 58. So your answer is C. Last one. Number 5. Which statement is true about the equation 42 minus 6 equals m plus 9? So we want to look at this. Let's rewrite this so we can see it a little bit better. 42 minus 6 equals m plus 9. Now, looking at our answers, it says, A says the value of m is 9 more than 42. So the value of m is 9 more than 42. The value of m is 9 less than 42. The value of m is 15 more than 42. Or the value of m is 15 less than 42. Now when we're trying to find unknowns, if you guys remember what I had told you before, if we take the opposite, the inverse operation, and kind of try and get this m by itself, we would have, let's see, if we added, y'all know I struggled with this, so hang on. We all struggled with this. If we add 6 to 9, that'd be 9, 10, 11, 12, 13, 14, 15. And we would have to take 6 away in order to balance the equation, which if we took 6 from 42, we would get 30, be 36. So the value of m is 9 more than 42. Would that be true? No, because it'd be 6. It would be right here. The value of m is 15 more than 42, because that is, when we balanced our equation, that's what we came up with. So it would be C. Alright guys, that is it for Friday for week 3. We are done. Hopefully this video uploads with no problem. When we come back on Monday, we're going to do some subtracting with line plots and some practices, and I think midweek next week we will be getting into angles, which should be mostly a review because we did talk about angles before we left. I haven't read completely through this. I don't think we're going to need a protractor, but if we do, there's an app for that, surprisingly, which I will share with you once we get there. So just to preview next week, we're going to finish up line plots by learning about subtracting with line plots. We're going to do some practices with it, and then we are going to jump right into angles, which I'm super excited about. Oh my goodness. So I hope you guys have a great weekend. I hope that the weather holds out. It does look like we're supposed to still get some storms in on Sunday again. So So hopefully y'all stay safe. Hopefully y'all have better power than I do, because I have just lost power constantly this last few weeks. But we're getting back on track, so it'll all be good. Have a great weekend. I will see you guys first thing Monday morning with the iReady shout-outs on Facebook and jumping right into day 1 of week 4. All right. Bye, guys.